T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition, engines full power, and liftoff. Go SpaceX, go commercial GTO 1.
Falcon 9 is pitching downrange.
M1D chamber pressure is nominal.
At T plus 30 seconds and counting, Falcon 9 has successfully lifted off from Space Launch Complex 40 at Cape Canaveral Space Force Station. During ascent, we tilt or gimbal the engines on the booster, and that turns the rocket horizontally, a maneuver known as a gravity turn. So the
power and telemetry nominal.
Healthy call out there from the rocket. As the rocket is still going up, it is also now heading horizontally away from the launch pad.
And moments ago, we throttled the engines
Falcon
down.
9 is supersonic.
We throttled the engines down on the first stage in preparation for max Q, or maximum aerodynamic pressure. This is a critical moment during flight because the combined stresses caused by Falcon 9 accelerating through the atmosphere and the ambient static pressure are at their greatest.
Max Q.
And there's that call out for max Q. Now the rocket typically needs to go about 17,500 miles per hour horizontally in order to avoid being pulled back down to Earth and get into orbit.
You can track our progress to orbit by keeping an eye on the Stage 1 telemetry in the bottom of your screen. Now we have several events coming up in quick succession. Main engine cutoff, or MECO.
Actually started.
Good call out. Stage separation, second engine start 1, or SES1, and fairing separation. And just as a reminder, we will not have any Stage 2 views today, including separation, and the remainder of our webcast will follow the Falcon 9 booster's return to Earth.
Now, main engine cutoff, or MECO, is where all 9 Merlin 1D engines shut down to slow the vehicle down in preparation for stage separation, which is where the first stage separates from the second stage. Followed by this, the MVAC engine on the second stage will light.
Trajectory nominal.
Good call out there. And the second stage will light, which is called out as second engine start 1, or SES1.
This engine burn will propel the second stage and the payload to orbit. In addition to these 3 major events, the fairing halves will separate shortly after SES1, though again, as we mentioned, we will not be seeing that tonight.
MECO.
As you just heard, we've just passed through many...
Stage separation confirmed.
Excellent call-outs coming in here from the nets.
MVAC ignition.
And good call-outs there. Now coming up in just a few moments, we should be hearing a call-out for fairing separation. Now both fairing halves on today's mission are flight proven, with one half flying for its 18th time and the other for its 14th time. And these will be retrieved by our recovery vessel Bob once they fall back down to Earth. We should be hearing
trajectories.
Good call out there. We should be hearing that call out for fairing separation in just a few moments from now.
Fairing separation confirmed.
And good call out there for fairing separation.
We are now at 3 minutes and 40 seconds into today's mission, with the next major milestone coming up just past the T plus 6 minute mark, which will be the first stage entry burn. For this entry burn, we'll relight 3 of the M1D engines on the first stage, starting with the center E9 engine, followed shortly after by the E1 and E5 engines. This helps slow down the vehicle as the rocket passes into the Earth's denser lower atmosphere. And we need to slow the rocket down to reduce the re-entry forces, which ultimately helps us recover and reuse the first stage.
Now, during the entry burn, Falcon 9 is decelerating by firing its Merlin engines, but the vehicle is still moving really fast, and this causes the vehicle to fly through Merlin's exhaust gases, and this deposits a layer of soot on the vehicle surface, which is why our flight-proven vehicles look the way they do. And that soot comes from the carbon-based fuel that Falcon 9 uses. Now, while we do have some pretty grainy views right now because it is so dark with the cameras from the booster, you can keep an eye on the speed and altitude of the booster at the bottom left-hand corner of your screen.
As we continue to make our way towards that entry burn, I want to take a couple moments here to talk about reusability, which is key to lowering the cost of spaceflight, which in turn enables more investment in critical scientific research. The Falcon 9 first stage that is supporting today's mission is flying for its 13th time, and while this booster is only on its 13th trip to space, we're working toward qualifying our fleet of Falcon boosters and fairings to support 40 missions each. And for those following along, we're currently at 29 flights of a single Falcon booster, which is absolutely phenomenal. Increasing Falcon's flight count provides valuable information and repeated reuse, which is a critical element for making life multiplanetary. Now we're just about 40 seconds away from the beginning of the entry burn, so keep your eyes peeled on that screen and watch the telemetry at the bottom of your screen where you'll see the graphics light up as the engines do.
Now, as a reminder, the booster flying on today's mission is flying for its 13th time, having previously supported NASA's Crew 8 mission, Polaris Dawn, the CRS-31 mission, to the International Space
entry burn startup.
To the International Space Station, and
Stage
more.
1 FTS has safed.
And there's that call out for the entry burn startup on the Falcon 9 first stage.
Stage 1 entry burn shutdown.
And good call out there for entry burn shutdown of the Falcon 9 first stage. Now, the Merlin engines on the Falcon first stage.
Trajectories remain nominal.
Good call out there. The Merlin engines on the Falcon first stage are optimized for sea level, and these achieve 190,000 pounds of thrust during ascent and descent. The single MVAC engine on the second stage has a much wider nozzle and is optimized to operate in space, producing 220,500 pounds of thrust in vacuum. Coming up in about 40 seconds from now, we should be hearing a call out for SECO 1, which will be the shutdown of the second stage MVAC engine. As a reminder, though, we will not have views of this milestone at the request of our customer.
Stage 2 has entered terminal guidance.
And good call out there. Now, immediately after that SECO 1 call out, we should have startup of the landing burn on the Falcon 9 first stage. Now, the landing burn is the final burn of the Falcon.
Stage 1 transonic.
Another good call out there. The landing burn is the final burn of the Falcon 9 booster, used to reduce the remaining speed of the vehicle in order to allow for a precision landing.
Stage 2 FTS has safed.
Another good call out there. And that landing burn is to allow for a precision landing on our drone ship. We should be hearing that call out for the first stage landing burn in just a few moments from now.
SECO.
Stage 1 landing burn.
And we are now waiting for Falcon 9 to land on our drone ship. Just read the instructions.
Nominal orbit insertion.
Great call outs there from the second stage while we're watching the first stage land.
Landing leg deploy.